Hello everyone, welcome to our channel AskPrep. In today's series on 11th grade physics, we will be studying Chapter 1, Physical World, in detail. Let's start the video. Starting with what is science? Science is a systematic and organized attempt to acquire knowledge about the surroundings through observations, experiments, and verifications. Next is scientific method. Several interrelated steps are involved in the scientific method. Some of the most significant steps are 1. Systematic observations. 2. Reasoning. 3. Mathematical modeling. 4. Theoretical prediction. Next is what is physics? Physics is a fundamental science concerned with understanding the natural phenomena that occur in our universe. It has many branches, such as mechanics, electromagnetism, thermodynamics, and modern physics. Between 1600 and 1900, three broad areas were developed, collectively known as classical physics. These areas are classical mechanics, thermodynamics, and electromagnetism. However, by 1905, it became apparent that classical ideas failed to explain several phenomena, leading to the development of new theories in what is called modern physics, such as special relativity and quantum mechanics. Next is scope and excitement of physics. The scope of physics is vast and covers a wide range of physical quantities such as length, mass, time, and energy. It deals with both the macroscopic world, like galaxies and the universe, and the microscopic world, like atomic nuclei and fundamental particles such as electrons, protons, and neutrons. The study of physics is immensely exciting as it explains natural phenomena with a set of rules, enabling a clearer understanding. The challenge of conducting imaginative new experiments to unlock nature's secrets and verify or refute theories adds to the excitement. Next is physics in relation to other sciences. Physics plays a crucial role in the understanding and development of other branches of science, such as chemistry and biology. 1. Physics in relation to mathematics. The study of physical variables led to concepts like differentiation, integration, and differential equations. Mathematical concepts are interpreted meaningfully through physics. 2. Physics in relation to chemistry. Concepts like X-ray diffraction and radioactivity have helped distinguish between various solids and refine the periodic table. Understanding bonding and chemical structures is facilitated by studying the interactions between particles. 3. Physics in relation to astronomy. Optical telescopes, both reflecting and refracting, enabled humans to explore space. The invention of radio telescopes revolutionized the study of astronomy. 4. Physics in relation to biology. The study of pressure and its measurement helped in understanding blood pressure and heart function. X-rays contributed to medical diagnosis, and electron and optical microscopes revolutionized medical science. 5. Physics in relation to meteorology. Discoveries in pressure variation studies have helped forecast the weather. Various other inventions in physics have opened new fields of study in science and social sciences. Next is physics in relation to technology and society. Advances in physics have led to new technologies and vice versa. Sometimes technology gives rise to new dimensions in physics, while at other times, physics generates new technology. Technological development is closely related to the application of science, especially physics. Physics has a dominant influence on society, helping humans develop ideas. Innovations such as digital communication systems, rapid mass transport, and lasers enabling bloodless surgeries have made life easier and more pleasant. There are four fundamental forces in nature that govern the diverse phenomena of the microscopic and macroscopic worlds: gravitational force, electromagnetic force, strong nuclear force, and weak nuclear force. Unification of forces is a central pursuit in physics. The electromagnetic and weak nuclear forces have been unified into a single, electroweak, force. Efforts are ongoing to unify the electroweak and strong forces. Conservation laws, including energy, momentum, angular momentum, and charge, are fundamental in physics. These laws are deeply connected with the symmetries of nature. Symmetries of space and time, along with other types of symmetries, play a key role in modern theories of fundamental forces in nature. Thank you for watching. We will be dropping notes in the description of this video. If you found this video helpful, kindly like, subscribe, and share. See you in the next video. All the best for your exams.